This lesson will give you information about joules and bonds. The first law of thermodynamics states that energy can never be created nor destroyed. Therefore, all energy changes in the universe involve the conversion of one type of energy to another. We will be specifically focusing in on chemical potential energy. Chemical potential energy is the stored potential energy in a molecule. As you know, some molecules are high in potential energy, like methane, and some are very low in potential energy, like water. And it's the change from one molecule to another that we can get an output of energy. Additionally, you can go the other direction from a low potential energy molecule to a high potential energy molecule that requires the input of energy. Joules are the standard unit of energy. We're going to start by looking at joules and calories. A calorie is the amount of energy, joules, needed to raise 1 gram of water, 1 degree Celsius. I'm going to show you how to do some of the starting calculations, and then you can finish the assignment after that. When the temperature increases in a sample of water, the energy rises in a predictable manner. This concept is schematicized in the diagram shown below. So we have our person here, and they need to climb up the steps, and going up one step requires 4 joules of energy. So to climb 2 steps would require 8, 4 on each step, and to climb up 3 would require 12, because again, 4 on each step. You can set these problems up with dimensional analysis. The question reads, based on the cartoon shown above, how many joules are needed for 1 gram of water to rise 12 degrees in temperature? So we have 12 degrees Celsius times 4 joules per 1 degree Celsius. And if you do that math, you'll get 48 joules. So this is for 1 gram of water. What if you have 5 grams of water from 20 degrees to 30 degrees Celsius? So instead of one little person in the picture, we have 5. The question is saying you're going from 20 degrees to 30 degrees. That would be 10 steps, or 10 degrees total. So again, we can set this up with dimensional analysis. 10 degrees Celsius times, now we're going to add in our 5 gram part, times our 4 joules per 1 degree Celsius, 1 gram, like this. And in this case, we still get the canceling of our units, and we're left with joules as our final value, and we'll end up with 200 joules. Let's do number 3 together, and then you can do the rest on your own. So we're microwaving a batch of water. 1 milliliter is equal to 1 gram of water. So my milliliters of water is 50. So my 50 milliliters is equal to 50 grams. And the change in temperature is 15 degrees Celsius. And my final unit, which in reality is known as specific heat, and this is specific to water, 4 joules per 1 degree Celsius, 1 gram. And if you do your math, 50 times 15 times 4, you'll get 3,000 joules. Put that over here. Okay, so you'll calculate some more joules, and then in part 2, you're going to look at energy in bonds. The energy in bonds is calculated in joules. And changing from one bond to another will change your input or output of joules for that reaction. So we're looking at a bonding well, and then a couple questions about how to change the bonding state and consider energy. Good luck.